This combined gas law, no one was credited. But what was put together here was Boyle's law and Charles' law. And the equation was simply written using this proportion. P1 V1 over T1 is equal to P2 V2 over T2. And if we cross multiply this one, our working formula will be P1 V1 T2 is equal to P2 V2 T1. The pressure and the volume of the gas are inversely proportional to each other, but are both directly proportional to the temperature of that gas. This is the combined gas law. Translating it to mathematical equation, we shall arrive with this formula. T is equal to volume times pressure over K. Or V is also KT over P. Or P is equal to KT over V. Or K is equal to PV over T. The constant here is the universal gas constant. With our working formula or working equation for combined gas law, pressure 1, volume 1 times temperature 2 is equal to P2 V2 T1. We can actually derive 6 formulas. In case you're going to look for P1, we can actually find for it by deriving its formula. Same as with V1, same as with T2, same as with P2, same as with V2, same as with T1. We can all derive the formula for these physical quantities. So let's do it. First, on the side, if we want to eliminate V1 and T2, dividing it both sides with V1 T2, we shall arrive with the formula for P1, which is P1 is equal to P2 V2 T1 over V1 T2. Secondly, if we want to have the formula for V1, eliminate on this side P1 and T2. Hence, your formula will be P2 V2 T1 over P1 T2. Am I right, class? And lastly, eliminate on this side P1 and V1 so that you can get the formula for T2. So T2 will be P2 V2 T1 over P1 V1. Okay, let's continue with our working equation. This time, eliminating the quantities on this side so that we can get the formula of one unknown. So, if we eliminate P2 and V2 on this side by dividing both sides with P2 and V2, this will be cancelled out. V2 cancels V2. P2 in the numerator cancels P2, but on the side, nothing is cancelled. So what's left is that your formula for T1 will be P1 V1 T2 over P2 V2. Next, eliminate on this side T2 and T1 so that we will have the formula for V2. So V2 will be P1 V1 T2 over P2 times T1. And lastly, let's have our formula for P2. P2, what should be eliminated in this side will be V2 and T1. So P2 will be equal to P1 V1 T2 over V2 T1. So we have 6 derived formulas from our working equation or working formula of combined gas law. This is the 4th formula for finding T1, the 5th formula for finding V2, and our 6th formula if we're looking for P2. Okay, so let's have the sample problem in your book to determine the changes in the final volume, temperature, or pressure of gases. Let's read the problem. The oxygen tank manufacturer used to produce 5-liter oxygen tanks at 2000 psi and 25 degrees Celsius. The statistics suggest that the 3-liter oxygen tank at 1500 psi is more marketable. What temperature requirement is needed to produce a 3-liter oxygen tank at 1500 psi? So what do you notice from this problem? Both of the pressures are expressed into psi unit, so we don't need to convert them. It's okay for them to be expressed both in psi units. While temperature, since the first temperature is expressed in degrees Celsius again, we need to convert it into Kelvin. The 25 degrees Celsius should be converted into Kelvin, which will become 298 Kelvin once you add 273, which is the conversion factor from degrees Celsius to Kelvin. And since the volume are both expressed in liters, they need not be converted as well. So let's work on it. So let's write down the given in the problem. Our initial conditions. The first volume of the oxygen gas in tank is 5 liter. At pressure 2000 psi, at temperature 25 degrees Celsius. So this is V1, P1, and T1. But we need to add here 273.15 or 273 to make the temperature in Kelvin. So from 25 degrees Celsius, it will now become 298 but expressed in Kelvin. For our final conditions, to produce a 3-liter oxygen gas in tank, the pressure must be 1500 psi. Now we need to look for the temperature of that oxygen gas in tank that will satisfy the conditions of this volume and this pressure. So obviously our formula for finding T2 will be T1 P2 V2 over P1 V1. So let's substitute the values. Our T1 is 298 Kelvin times final pressure is 1500 psi times final volume, which is 3 liters, divided by the product of P1 and V1. So P1 is 2000 psi times 5 liters. So the liter here in the numerator cancels out the liter unit in the denominator. The psi unit pressure in the numerator is cancelled out by the psi unit for pressure in the denominator. So what's left in the formula is Kelvin, which is obviously a unit for temperature. the final temperature of the oxygen gas to satisfy the final conditions of volume and pressure given in the problem. So, if you're going to compute it, 298 Kelvin times 1500 times 3. The product of the numerator should be divided by the product of the denominator, which is 2000 times 5. Final value for T2, which is 134 Kelvin. So I hope you understand it, class. So that is combined gas law. The gas law which combines Boyle's law and Charles' law together, stating the relationship of volume, temperature, and pressure of a gas at constant, which is universal gas constant.